Machine learning is a method of data analysis that automates analytical model building. It is a branch of artificial intelligence based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. Because of new computing technologies, machine learning today is not like machine learning of the past. It was born from pattern recognition and the theory that computers can learn without being programmed to perform specific tasks. The iterative aspect of machine learning is important because as models are exposed to new data, they are able to independently adapt. They learn from previous computations to produce reliable, repeatable decisions and results. It's a science that's not new, but one that has gained fresh momentum. While many machine learning algorithms have been around for a long time, the ability to automatically apply complex mathematical calculations to big data, over and over, faster and faster, is a recent development. Here are a few widely publicized examples of machine learning applications you may be familiar with. For example, a heavily hyped, self-driving Google car. Online recommendation offers such as those from Amazon and Netflix. Knowing what customers are saying about you on Twitter. And fraud detection. One of the more obvious, important uses in our world today. Why is machine learning important? Resurging interest in machine learning is due to the same factors that have made data mining and Bayesian analysis more popular than ever. Things like growing volumes and varieties of available data, computational processing that is cheaper and more powerful, and affordable data storage. All of these things mean it's possible to quickly and automatically produce models that can analyze bigger, more complex data and deliver faster, more accurate results, even on a very large scale. And by building precise models, an organization has a better chance of identifying profitable opportunities or avoiding unknown risks. To create good machine learning systems, you will need data preparation capabilities, basic and advanced algorithms, automation and iterative processes, scalability, and modeling. There are some differences in nomenclature used in machine learning versus traditional statistics. For example, in machine learning, a target is called a label. In statistics, a target is called a dependent variable. A variable in statistics is called a feature in machine learning. And a transformation in statistics is called feature creation in machine learning. Two of the most widely adopted machine learning methods are supervised learning and unsupervised learning, but there are also other methods of machine learning. Here's an overview of the most popular types. Supervised learning algorithms are trained using labeled examples, such as an input where the desired output is known. For example, a piece of equipment could have data points labeled either failed or runs. The learning algorithm receives a set of inputs along with the corresponding correct outputs, and the algorithm learns by comparing its actual output with correct outputs to find errors. It then modifies the model accordingly. Through methods like classification, regression, prediction, and gradient boosting, supervised learning uses patterns to predict the values of the label on additional unlabeled data. Supervised learning is commonly used in applications where historical data predicts likely future events. For example, it can anticipate when credit card transactions are likely to be fraudulent or which insurance customer is likely to file a claim. Unsupervised learning is used against data that has no historical labels. The system is not told the right answer. The algorithm must figure out what is being shown. The goal is to explore the data and find some structure within. Unsupervised learning works well on transactional data. For example, it can identify segments of customers with similar attributes who can then be treated similarly in marketing campaigns. Or it can find the main attributes that separate customer segments from each other. Popular techniques include self-organizing maps, nearest neighbor mapping, k-means clustering, and singular value decomposition. These algorithms are also used to segment text topics, recommend items, and identify data outliers. Reinforcement learning is often used for robotics, gaming, and navigation. With reinforcement learning, the algorithm discovers through trial and error which actions yield the greatest rewards. This type of learning has three primary components: the agent, the learner, or decision maker. The environment, everything the agent interacts with. And actions, what the agent can do. The objective is for the agent to choose actions that maximize the expected reward over a given amount of time. The agent will reach the goal much faster by following a good policy. So the goal in reinforcement learning is to learn the best policy.